Welcome back, everyone. Today, we're diving into a forensic science report that honestly, it reads more like a detective novel. We're talking about a killer that can, quite literally, vanish into thin air. So, let's just jump right in with a pretty chilling question. Can a life-saving medicine also be the perfect murder weapon? I mean, it's a terrifying thought, right? And that's the central puzzle we're going to try and solve today. You know, for millions of people, insulin is nothing short of a miracle drug. It keeps them alive. But the thing is, for forensic scientists, it's a total ghost. It's a killer that can leave almost no trace, which makes it incredibly hard to figure out what really happened. Okay, so why is it so hard to find? Let's get into the nitty-gritty, the science behind this vanishing evidence, and really understand why insulin is such a ghost in the system. All right, to really get a handle on this challenge, we've got to understand the playing field, and that field is post-insulin, postmortem toxicology. It's basically the science of finding drugs and poisons in a body after death to figure out what happened. It's, a super critical part of solving unexplained deaths. But, as we're about to see, insulin, well, it pushes this science to its absolute limits. So, this brings us to the main hurdles, the big problems for the forensic teams. First off, you've got something called postmortem instability. Basically, insulin just breaks down super fast in the blood after someone dies. Then there's surface adsorption. And this is wild. It literally sticks to the sides of standard lab tubes, so it just disappears from the sample you're trying to test. On top of that, it has a high molecular weight, which is just a fancy way of saying its size means you need special, pretty uncommon equipment to even spot it. And maybe the biggest problem of all, structural similarity. The synthetic insulin people inject is almost an identical twin to the insulin our bodies make. It is a genuine forensic nightmare. Okay, so all that fury is one thing, right? But the paper we're looking at today is all about a real-world case that makes these problems, well, very real. Let's get into the story of how a case went cold and an unexplained death that just didn't add up. So here's the scene. A 63-year-old man is found dead in his home. Everything's quiet. There are no obvious signs of foul play, no struggle, no injuries. I mean, to the naked eye, it looks like nothing is out of place at all. So, of course, the investigators do the standard thing. They run a full toxicology report, looking for any common drugs, poisons, anything. And the result? Zilch. Nothing. Absolutely clean. And just like that, the case hits a brick wall. The cause of death is officially a complete mystery. And for months, that's exactly where it stayed. A total cold case. But then something changes. And we're not talking days or weeks later. We're talking a full 9 months later. A revelation comes to light. And this cold case suddenly gets very, very hot. I mean, just look at this timeline. It's so strange. Day 1, the man is found. By the end of week 1, the toxicology screen is back, it's negative, and the case just stalls. And then, just silence, for 9 whole months. It's not until then that a crucial tip comes in that changes absolutely everything and makes them go back and reanalyze that original blood sample. So, what was this huge, game-changing tip? Well, 9 months after the fact, the toxicologist is finally told a few key things. 1, the victim was a known diabetic. 2, he was prescribed Humalog, which is a synthetic insulin. 3 empty insulin syringes were found near his body. And 4, a suicide note was discovered. All of this crucial information was somehow missed or not passed along, and now it changes the entire investigation. So now, armed with this totally new context, the lab goes back to that same blood sample, the one that's been sitting around for 9 months. But this time, they're looking for one specific thing: insulin. So let's look at how they interpreted these new clues and the really shocking result they came back with. And they found it. After all that time, after 9 months of degradation, they actually detected the synthetic insulin Lispro to be exact. The concentration? 1.1 nanograms per milliliter. Okay, so there it is. They found it. Case closed, right? Well, not so fast. Because here's the twist, and it's a direct quote from the paper. The concentration found in our case is within the therapeutic range. What does that mean? It means the amount they found is considered a totally normal, safe level for a diabetic person taking their medication. So this leads us right to the heart of the puzzle. If the level is therapeutic, then it wasn't an overdose, was it? This is where the real forensic detective work kicks in. Because that simple number, it's actually hiding the real story. Okay, here's why that 1.1 number is so deceptive. Think about it. First, time degradation. 9 months have gone by. That insulin has had a long time to just break down on its own. Second, poor storage. The sample was just kept in a fridge at 4 degrees Celsius. It wasn't frozen. That's like hitting the fast-forward button on decay. And third, the wrong container. It was in a simple dry tube, which we now know insulin loves to stick to. So when you add all that up, what's the only possible solution? The amount of insulin in his system at the time of death must have been enormous for any of it to be left at all. And just look at this comparison. The gap between what should have happened and what actually happened is just staggering. In an ideal world, the sample would be in a special tube with preservatives and froze immediately to stop all degradation. But in this case, it was a basic tube left in a fridge for 9 months. The result is a massive loss of the very evidence they needed. All right, let's put all of these pieces together now. It's time for the final forensic verdict. What is the story the science really tells once you finally have the whole picture? And when you lay it all out like this, the picture becomes crystal clear. Yeah, you start with that 1.1 nanogram concentration, which on its own looks therapeutic. But then you have to factor in the roughly 48 hours before the sample was even taken. Then the 9 months before it was analyzed, and of course, the awful storage. When you look at all of that together, the final interpretation is pretty much unavoidable. An overdose was highly probable. You know, the researchers who wrote the paper, they put it perfectly. And this quote really says it all. The very fact that they could identify any insulin lispro, even at that low concentration, is strong evidence that the amount at the time of death had to have been much higher. So what's the big lesson here? What's the key takeaway from all this? It's simple. In forensic toxicology, context is absolutely everything. The number you see on a lab report doesn't tell the whole story. In fact, without the full context, it can be worse than meaningless. It can be downright misleading. And that really leaves us with one last pretty sobering thought, doesn't it? I mean, this case was only solved because of a lucky tip that came in 9 months late. So you have to wonder, how many other vanishing killers have slipped through the cracks, completely undetected, all because that one crucial piece of context was missed? It's definitely something to think about.